we were talking about transformation of quadratic functions in standard form, and we want to graph quadratic functions and determine whether the graph has a minimum value or a maximum value from the a value. So this has an a value, which is -2. So I know right off the bat that I'll write these down right here. A value is -2. And so because of that, I know my graph is going to open down. The b value is going to be equal to 0 because there's no b value there. And the c value is equal to 4. So I know that my y-intercept is going to be the point 0.04. So 0, 4, right there, that is my y-intercept. So the line of symmetry, when we calculate that, we remember that the equation is x equals -b over 2a. And so we can substitute the values in that we know. So the things that stay the same, x equals negative, then we're going to substitute a value in for the b and a value in for the a. So the b value in this case is 0, and the a value in this case is -2. Well, we have a 0 in the numerator, so our line of symmetry is going to be equal to x equals 0, which in this case is the x-axis. So x equals 0. And now we know that it opens down. We know that the line of symmetry is x equals 0. And we know that the vertex is always on the line of symmetry. So in this case, we don't have to actually calculate our minimum and maximum value because we know the graph opens down and we have the point 0.04. So our maximum value, in this case, our max value is the vertex, and our coordinates for the vertex are 4, 0. The vertex and the y-intercept happen to be the same this time because our line of symmetry is the x-axis. So when we go to graph this, we know that it opens down, and our scale factor here, our a value, is -2. So I know that it's going to go over 1, down 2. And then I know that if it goes over 2, it's going to go down 8, which will put me down here. The other way that we can do to calculate where these points are is we can substitute them in. And so what would be an easy point to pick? To figure out where the next point would be, I would pick 1 as a point, substitute it in. So if we say the function evaluated at 1 is equal to -2 times 1 squared plus 4. So 1 squared is 1 times -2. So that's -2 plus 4. -2 plus 4, so that's +2. So the function evaluated at 1 gives us the y value of 2. So 1, 2 is a point on the graph, and that's what we have graphed here, this point right here. Because the line of symmetry, both sides are congruent, if I know that I have to go over 1 to get to this point, I also have to go over 1 to get to that point. And so that's how we can get 3 easy points. We have the vertex, and then we plugged one number in, which was the value 1, to get those 2 points, and then we can draw a pretty good graph. The domain for all parabolas, there's no restriction on the domain, so that's going to go from -infinity to infinity. The range, in this case, that's talking about the y values. So the y values are going to stop up here at +4, but they're going to start down here. This arrow means it goes to negative infinity. So the range is going to go from negative infinity to positive 4. And then decreasing and increasing. As we go along the graph from left to right, our pen follows it. It looks like our pen's going up. So our pen is going to increase all the way until x equals 0, which is right on the y-axis. So it's going to increase from negative infinity all the way to 0. And these are talking about, decreasing and increase are talking about just the x values. When it starts decreasing at x equals 0, and it's going to decrease all the way to infinity. So 0 to infinity, neither one are included, so we use the parentheses. And then we can take a look at a graph. We have a graph right here. The point that we calculated was 0, 4. We also calculated a point of 1, 2. And we calculated a point of 2, negative 4, which is right there. And whenever we have if we calculate one side, we can calculate the other side. So here's 2, negative 4. That is 1, 2 over from the line of symmetry. So now I can just count over 2 again, 1, 2, and I see that there is another point on the other side. Still at the y value of negative 4, but 2 to the left of the line of symmetry.